Okay. Then anything else?
2, 3, 18,
2,
19.
3,
2,
3,
18,
19.
10.
2, 3, 8, 9.
18, 19.
18,
19.
2, 3, 18, 19. Okay. Got
2,
good. Third
6,
term.
and 3,
2,
7.
6,
2,
18.
6,
2,
18.
18, 6, 22.
One at a time.
6,
22.
18, 20.
6, 18,
18,
22.
Okay.
20.
22.
ma'am.
Oh, 22. Okay. So anything else?
No, ma'am.
And
No.
this much.
Okay. So these are the terms which you got in the leftmost, means you, that side, the highest one. That means here it's already an indication that we will be having two variables out. Like two variables won't be there, only two variables we can frame this. Right. Then comes your pairs. How many pairs are left out?
Ma'am,
Many.
12, 28 and 22, 30, 13, 15. 12, 20, 28,
12, 8, 20,
28.
28, right? Then
12 and 28.
12 and 28. Then
And 22 and 30.
22 and 30. Okay.
13 and 15.
13 and 15. Good.
Yes, ma'am. Ma'am, that 12 and 8 is not there.
No. Okay.
Ma'am, 0, 8 to 10 will
0,
also
8
be
to 10
there.
is there already.
0 to 8. This is 0, 8.
All the same now. See, I am writing they are covering 0 to 8, 10 or 0, 8 to 10. What is the term coming? Same, no? Both have the same term. Check out.
Yes, ma'am.
Yeah. Yes, ma'am. Go ahead with the pairs.
Ma'am, pairs completed. Another one left is 25.
Yeah, 25. That was like 125. Okay. So this one are pairs. Just for our verification, because we are doing in virtual mode. So earlier I never used to do like this. So this is a cross check. So this is the fifth term. This is sixth term, seventh term, and this is eighth. So that means my function now will be, we will frame. I don't know what is the function. A, B, C, D, E I gave. What is that I gave? A, B, C, D or W, X, Y, Z?
A, B, C, D.
ABCD.
Okay. So A, B, C, D. So now for this term, what is the condition came? Like what are the terms? A, B, C,
A
D.
dash. Okay. 0, 0 bar, 0 bar, 0 bar, 0 bar, 0. Yes. Yes.
Right? Okay. 0 blank, 0 blank, 0. Okay. Second term 2, 3, 6, 7. So now
0.
this, okay, one second. This term will be written here. Now A bar, C bar, E bar. Okay. Now second term.
0, 0 dash bar 1, 0. 1 bar. 1 bar.
Yeah. Okay. So this term over here it is A bar, B bar, D. That's it. Okay. Now what about this?
Bar 0, 0. No, ma'am, bar 0, 0. 1 bar.
So this will be your B bar, C bar, D. Okay. Third term is done. Fourth term.
Fourth term. Bar 0 bar 1, 0.
So now this one will be your B bar, D, E bar. Okay, now comes your pairs. Plus this pair,
Ma'am, bar 1,
here it will
One.
be one.
0, 0.
So now this will be your B, C, D bar, E bar. What about this?
1
Ma'am, voice is breaking.
Ma'am, you are muted.
Yeah, some fellow has done that. They have put me out of the meeting also. No, there's some network issue going on. Right. So 22, 30, ma?
1
Yeah.
bar 110.
Okay. So this one will be your A, C, D, E bar. Okay. Then afterwards 7.
Ma'am, 13 and 15 is 0,
Yeah.
1, 1 bars 1.
Okay. So this will be A bar, B, C, E. Okay. Then 25. So your 25 will be normal. All 4 digits will be there, na?
Yes, ma'am.
Yeah.
Ma'am,
25.
11001.
0, 0, 1. Will do?
Yes, ma'am.
16 plus 8 here. So it will be plus A, B, C bar, D bar. So now this is your function, right? So it's a very tedious task, but this is how we will give, right? First level, second
No,
level,
ma'am.
third level. Yeah.
Ma'am, I got 3 extra terms also.
That means your comparison might be wrong.
No, ma'am, I
I
also
got
got in the pairs.
I also got in the pairs. See, procedure is like this. I'm not saying this is the final one, right? So today another example I will show in the slide, right? See, the levels of 1, 2, 3, 4 will go like this only. Then afterwards we will frame the function. Procedure first understand. Okay, so procedure first understand, then afterwards we will do. Okay, so there's nothing wrong. If there are unpaired things, we have to include that in the function. There is nothing wrong. Okay.
yes,
Right.
ma'am.
Now, hold on. Now, the function is framed using these terms. What? These are the min terms available which are covering the whole function. Right? Now, can you point out among these min terms which claim themselves that they are framing the function, minimized function, which is very essential? Among all these things, like essential means what? Without this, the function cannot be framed. Can you point out this? Right? Like what we will say after the min terms reduction or minimization, we will try to evaluate, like fine, we have reduced the system, but still we have to point out which min terms are more essential to frame the function. All are good only, but some are essential, right? In order to do that, what we will do is there's a simple chart. Okay, so just a second.
Ma'am, we have to separate prime implicant.
Yeah, I will say prime implicants only, but prior to that, we will say essential implicants. You have the idea of prime implicants? You have the
Very
idea?
little
Little
idea.
bit.
Little.
Okay, so we will do that. Okay, so in order to do that, it's a simple chart, very easy to understand. Please concentrate. Right, your first thing is you have to make again another separate table, right? And write down everything which are covering here, like M0, M2, M8, right? M10, right? Okay, and there particular terms over here, whatever terms are there, right? So your terms I have erased them, so you can write the terms. Okay, so then 2, 3, 6, 7. 2 is already there, and 3, 6, and 7. So similarly, 18, 19. So like that we will try to cover. Okay, so I'm just giving the procedure. I'll show the example. Right. So M12, M28, M22, everything we will write here, and their respective terms we will write. Okay. So terms means what? Just now I raised that terms. That also we will write here. Right. Now go row wise. Right. For example, the first term is there. First term covers what? These are the terms, right? These are the min terms it covers. So what we will do? We will M0, M2, M8, M10. Just give a tick. Right. Now second term covers 2, 3, 6, 7. 2, 3, 6, 7. Right. Similarly, 2, 3, 18, 19. So third term. This is third term. 2, 3, 18, 19. So like that we will have. Right. So if you are so confused, please try to write like this also. It's better, so that don't get confused. So every term will be having a cover of min terms. Right. Now after filling up all these things, just have a glance at your table. Right. Row wise we will finish. Are you able to follow? Row wise finish it. Right. Then afterwards, see the columns. See the columns. Right. Whichever column will have only one tick. Only one tick. That's supposed to be the essential prime implicant or essential min term we will tell. Again, I'll give a recap. First thing is take a table, then fill up all the min terms that have been squeezed at every levels. Then write them there, right? Terms over here, and then separate them. What are the min terms that each term is covering? Just give a tick. Then afterwards, we will try to see the column wise, whichever column will have the least. Whichever column will have the least means only one tick. That one we will round. For example, if this is having only one, so we will say M0 is essential. If for example here at till this level, this is essential, this is essential, this is essential, this is essential. So we will say these are the essential ones. Why? Because they have no other things. Now this is not essential. Why? We already have 3 ticks. Only one tick should be there. Is that clear? Is that clear? So now let's see one example. I will share the screen. So this already a worked out example from the internet source only. So here for time being, what they have done is they have used a 4 variable. Okay, a 4 variable because it's very easy to understand. Okay, so right. So now just check out. I'm sharing the screen. Just an example already available from the internet source. You can just see. Now it's getting loaded. Wait. Okay. Something it's given like this. Like it's a 4 variable. The map is like this. Okay. Right. They have told you you can use a K-map, but specifically they told use a QM method. That means tabulation method. Okay. So now first step, divide all the midterms and don't care of a function into groups. Now what is group? What do you mean by groups? See, first of all, this is the procedure. Are you able to listen or not?
Yes, ma'am.
Okay.
Yes, ma'am.
So first
Yes,
thing is, yeah, first write down. Okay, write down the terms. Right. So separated midterms and max terms. Okay. I think this is clear. Please note down this because I will not be showing the slides, all the slides. I will give a break that time. So you write down what are the terms available. Okay, so 3, 5, 6, 7, this one. Then afterwards, next step is we have to group them. So yesterday notation, what I was thinking, I gave 0, 1, 2, 3. Like that, these people are giving G0, G1, G2. It's a same notation. Okay, so grouping is fine. Right? Now, if you see here don't cares also are a part of the group. They have not separated them. Don't cares are also part of the group. Don't take it differently. Grouping is fine. If there is flaw, please point out. Sometimes there will be flaw. So I should see how many people are attentive also. Yeah.
Ma'am, due to this inclusion of don't care functions, do there is a change in the method, or we have to do in the same way?
What is that one? Come again.
Ma'am, due to this don't care terms,
Hmm.
is there any change in the method?
Yes, don't care terms are supposed to be a part of the system because we are using, just remember the theme when we are having don't cares, we are making them a part of the system and then we will see whether they will be utilized or not. Correct?
Okay, ma'am.
Yeah, because that time what did we do? We have pointed once and afterwards green crosses also I have kept. If they are being utilized, I will do. Otherwise, I will leave them. So, first initial grouping, I will use them. And afterwards, towards the end, while framing the term, I will remove them. What is the big deal? Is that correct? Satisfied? Hello?
Yes,
Yes,
ma'am.
ma'am.
So, right. So now 8 law here. So 2 supposed to be a don't care. It's a part of the system. 9 is also there. It is used in the system. 15 also framing. So we have the groups like this. Right. Now next level. So next level is what? We will try to merge them. See, everybody will have their own way. See, merge mark and all need not put. You can have your own terms. Like what are all framed. So this level you already know. Everybody will have their own ways to represent. So I normally prefer you people all of that keep it in a landscape mode. Your what text? Sorry, what is that notebook? Then write all the levels. Right. So first they have paired it and see how nicely they are utilizing the don't cares. 2 is a don't care, but nicely it is being utilized for pairing. Is that correct? Somebody has asked me that down. Yeah, is that correct or not?
Yes, ma'am.
Yeah, so please use that. Okay, so now then afterwards group 2, 3, 7 is there, 5, 7, and superbly they have used, 9 is there, don't care, they have used, 7, 15. So this one I think you can do that, right? And see here, there is a blank we are using and they are using a notation called B. Okay, so we use a blank, doesn't matter. Okay, B means there is nothing is there. Okay, so here we will have one variable reduction, right? Next. So then afterwards, it goes on. Right. So next level, 4. Correct? Right. Repeat the step 2 until no merging is possible. Is that correct? So they are doing a tick mark and everything they are repeating. So this till this level, I think you people also can do. Can you just re-verify? See, I am again showing the first one. See, note down this, then do it on your own. Don't wait for the answers to be shown. 3, 5, 6, 7, 10, 12, 13. 2, 9, 15. See, once you practice on the small one, the same thing will be applicable for the big variables also. Right. And there is a VHDL coding for this system. Right. That will be gripping whenever we do the VHDL coding. Okay. So anyway, so till this level that fellows have shown, so you can have a cross verification. I'll give you 5 minutes time. So when you are done, at least 1 or 2 should do that. I don't expect everybody to do. That's impossible. Aim for more mergings. That means more pairs and more quadruples, more octaves. Octave level is not there, that is sure. I think we have gone only here. This example has gone only for 2 levels. Right? Are you able to get 4? Still no merging possibilities. So these are the things which have come. 0, 2, 2, 3, 6, 7, 2, 10, 5, 7, 13, 15, 9, 13, 12, 13. These are the possible things. You guys are there or sleeping? Then afterwards you can just see. I kept the other way around. Right. I kept terms this side, I kept mean terms here. So what are the essential prime implicants? See here. You are able to see?
Yes, ma'am.
Yeah, don't cares are excluded. See here. Like means we are utilizing them by framing the main terms and then framing the essential one. We are not keeping them as essential prime implicants. Apart from that, we are choosing from the other bin. Okay, so you can use the min-term identity like this side or this side, anything will do. Right. I have the practice to keep the terms this side and then min-terms like this. It doesn't matter, same. Right. So then afterwards you can check out whichever column will have only one. They are essential prime implicants. See, essential prime implicants, please don't follow this method. Follow what method I do. After framing till here, afterwards follow that and give me what are the essential prime implicants. Please don't include any, don't guess, because this will be a little confusing for you.
Ma'am, I have a doubt.
Yeah, please go ahead.
Uh, means after finding some terms, we are doing this method of ticking and seeing in which column there are least number of ticks, and then for that column we are writing those terms. Means, I am not able to understand why are we excluding the other terms.
See, now if you can check out, if there is only one tick there, that means it is covered only one time. Okay, if there are more than one ticks, that means it has been covered more times. So more times are there means that means they are not essential. They are a part of the system. That's all. If that particular one is there, without that the system cannot be framed. Essential means what? Essential means without that the system cannot be framed. That's why I am telling that they are essential. See, now tell me, simple. I am saying, for example, this one, right? There are three ticks here, right? I am saying that in these three terms, M2 is covered. Okay,
Ma'am,
so
screen is showing the other
oh,
PDF. Means
sorry. I'm sorry. I'm sorry. Yeah. See, in this particular example, what I have shown, right? So this particular min term 2 is covered by three terms. Okay, so this is one term, this is second term, first term.
screen is blank.
Screen is what?
Means it's showing black.
Blood. There is some problem now. I think there is some network issue. Blurred it is for everyone?
Yes,
Ma'am,
ma'am.
it's fine now. It's fine now.
Yeah. Okay. Right. So now what I was telling is, see, in this particular 2, M2 is covered by 3 terms, right? So that means it shows that whether this term or this term or this term, in any of the terms, this min term is being portrayed. But whereas this situation, there is no other term is bearing this min term. So that's why I can say that this particular one is a essential, whereas this one is not essential because it is spreaded over 3 terms. That's the example I am telling. Why it is essential means because it is covered only once. For example, here in this one, M8 is also essential because only one term is bearing it. Without that, it cannot be. Okay, so I think this explanation should do. I'm telling that they are essential, they are not non-essential. Non-essential, I'm not telling the other one. I'm telling among that which is essential. All the terms are required. In that, who is essential? Okay?
Ma'am, can non-essential be termed as don't care?
No, there is no non-essential. That's what I was telling. There is no non-essential. They are only essential.
Okay.
So now, what next? Did you get the function? So what are the, after that, how much, this much you want? Minimum expression is this much, you can cross verify. Are you able to get the same in mass function? Like 1, 2, 3, 4, 5. 5 terms are there. So I think reduction is 2 quadruples and 3 pairs. Right. So if anybody has gone to the essential ones, can you please tell me what are the essential prime implicants to that level if anybody has gone? Or you can give me in the chat box also, no problem. Who are essential? If anybody has gone to that level, please tell me. What are the essential prime implicants? Just see, I am sharing one screen where it is done in my method, what I have taught. Just see this. This is not the same example, different example. Okay, just check out how they got. So after finishing off all the clubbing, so they kept the terms, right? So I used the tick marks and they have used the cross marks. Okay, don't worry. Right. So what are essential here? 9 is essential and 14 is essential because they have only one single cross. Are you able to follow everyone?
Yes, ma'am.
Try to get that. See this at this level. This is the only thing what I have. Yeah. Yes, mute yourself. Who is that? Yeah. So for finding the essential in the previous example, what did you get? Like this is just an example I told. How much you got? Anyone? This particular batch is very slow. Why? How come nobody has done till now the prime implicant thing? It's taking a lot of time or not?
Ma'am, B dash and CD bar.
No, no, I don't want the
Sorry,
terms.
will
I
be the
want
essential.
only the min terms. No, Hiranmaya. I just want the min terms. Who are essential min terms?
Ma'am, 0, 3, 5, 6, 10, 12.
Oh, all are essential, Mama. Everybody? How many of you are supporting
9
me?
and 15.
Yes, Divya?
Same, ma'am.
Same.
Except
Okay,
7 and
Sahil?
14.
Yes, Sahil?
Yes, ma'am. 7.
Oh, 7 became essential. So now what do you understand here? It's the total minimization procedure using the don't cares you have used, and while framing the prime implicant chart, you have not used the don't cares, right? So, and again in that, the prime implicants you got what? Only one. Is that correct? Only one term, right? How many you got? I have no idea. Somebody told only 7.
They got 7 terms.
7 terms. 7 terms means 7 essential things. Essential, how many terms you got?
6 terms, ma'am, total. Essential.
Yes, ma'am, 6 terms.
6
Ma'am,
became
6.
essential. 6 terms became essential. So did you follow the same way what I have told?
Yes, ma'am.
Sure?
Yes, ma'am.
Like this only. Like this only?
Yes, ma'am.
Okay, right. Okay. So right. So now you can just practice some more if at all you want. Right. Otherwise we can move to the next. Okay. So now next topic what we can do is, since we are with the minimization, then what is the next option? We are able to frame the circuit in a smaller manner. Is that correct? Right. So now this is a part of your, maybe which book you are following, by the way?
Morris Manno.
Modus Manno. Okay. So Modus Manno not required and all. So for examples you can just check out. Right. So now you should be able to understand that we can understand the theory behind what is the problem given, assign some variables, make a truth table, then afterwards deduce a Boolean expression, then try to minimize it and frame the circuit. This is what the gist of the last few classes. Is that correct? Essential minimization, you can use any procedure. I am not saying that. Okay, is that correct? Anything
Yes,
else we
ma'am.
have?
Yes, ma'am.
Yeah. So now, what did you understand from this? These are the basics of the logic gates, right? We are using basic gates and universal gates to frame the circuit. But till now, in the problems, I have not mentioned a objective. Like for example, I have a real practical system. I am having 3 inputs. Okay, so consider a staircase problem, right? I have inputs, that means switches at the ground floor. Okay, so can I have a logic behind glowing of the lights at every floor, right? That means how I want, maybe I may want 2 at a time. Okay, just think, I have 3 stories, like 3 stairs, right? All the stairs will have 3 lights, right? And my switches are at the ground floor. Imagine, visualize, right? So I want only 2 stairs bulbs to be glow, and every time, again I can put some more things. Every time, first one and the third one should not repeat. Something like that. Like that means I can put more constraints on that and make a logic circuit. Are you able to visualize that? 3 switches and then how the output should be there. So that type of logic also we have to develop. That means we have to understand the problem, make the truth table and then do. So such type of problems I will start working out. Is that okay?
Yes.
Yeah. So any other practical problems you want to discuss, please discuss. Like, because see, once I entered into the practical problems, prior to that, did you face anything like this? Because you might have done in your digital, no? That's what we call that as combinational circuits, because we have a task. So we will do the combinations of logics and then make the logical circuit. That means prior to that we will have all the listed constraints, right? Then try to understand, then put it mathematically in a Boolean expression we have to put. Prior to that we have to keep a truth table, right? Following all the constraints. Right, now please think any practical problems you have, like any practical problems you have come across, you want to discuss. All the time I will be shouting and you will be listening, not the, doesn't matter, no? It should not be. Right? So any such type of logics you have developed, the Cyborg Club people? No one? Okay, so let me pose one problem. You have a 7-segment display. Did you see a 7-segment display? Something like this. So you will have LEDs connected like this. Right. So can I have a pattern of glowing? Like I should have a digital numbers 0, then afterwards 1, then afterwards 2, then 3. Can I have this all glowing? Yes. Can we develop a logic like that? So I have to have some switches with me. When I use the switches, this number should be exhibited. Like just see, in order to exhibit this 0, how many switches are required? How many switches has to be highlighted? 1, 2, 3, 4. Right? Is that correct? 4 LEDs has to glow, na?
Yes, ma'am.
Yeah, that's all. So total I will have 1, 2, 3, 4, 5, 6, 7. 7 switches with me, and then I should develop a combinational logic so that every time I have to have one number displayed. Okay, so I am going very scratch level. That means manually I am changing the switches and I am seeing that output. Happy I am. Right. You can put automation in that also, because you are now this generation. We can put automatically fix a timer circuit I can use, and then 0, 1, 2, 3, 4, 5, 6, 7 I had there. Again I can repeat 0, 1, 2, 3, 4 like that I can repeat. Is that correct? Did you see these numberings in the railway stations and all? You have na this display system.
Yes, ma'am.
Yes, ma'am.
Yeah. So we have like the truth behind it is we have a combinational logic, we have some rules in that, and then that particular rules this system has to obey, right? So this is what the theory behind the development of a combinational logic, right? So we will discuss about the combinational logic tomorrow. Actually today really I'm not feeling good, ma, so I'm just leaving 10 minutes prior. Okay, so tomorrow class I will see, right? Tomorrow class or Monday class when I have
Monday.
Ma'am, Monday.
Okay. Yeah. So you can just work out some problems which are available in Morris Vano using Quern-McCluskey method or K-map method, everything. So again, try to implement in the NAND and NOR. Okay. So try to do that. Then afterwards you can understand. Right?
Ma'am,
Is that fine? Yeah.
ma'am,
Yes, ma'am.
ma'am, can you suggest any book to practice problems?
Seriously, there are no books now. Okay. Okay. Let me see. If I have an e-copy, I'll share with you. Right? There should be some 4 or 5 e-copies are there with me. So I will do that. I'll do that. Okay. Otherwise, let me frame all the questions and give you an assignment to practice.
Yes, ma'am.
Okay, ma'am.
Yes,
Thank
ma'am.
you. Thank you so much. Seriously, I'm not well today, but somehow I cannot miss the class. So I think this particular problems, class came on, you can just work out. Okay, ma'am. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Okay, ma'am.